Good morning, dear students. In previous period, we discussed how distribution of electrons takes place in different orbits as well as in cells, and maximum number of electrons present in cell K is 2, and second orbit it means in L cell is equal to 8 electrons. Third orbit or M cell is equal to 18 electrons, and fourth orbit or N cell is equal to 32, and so on. It indicates the maximum number of electrons that can be accommodated in the outermost orbit is 8. Electrons are not accommodated in a given cell unless the inner cells are filled. It means the cells are filled in a stepwise manner, and also discuss some few examples how the electrons are distributed or schematic atomic structure of the some elements. Yes, today let us see what is meant by valency. Yes, my dear students, the electrons are present in outermost cell of an atom are known as valence electrons. For example, hydrogen, only one electron is present. That is termed as what? Valence electron is 1. Valence means the electrons present in the outermost cell of an atom are known as valence electrons. Yes, my dear students, they govern the chemical properties of atom. It means the atoms of element have a completely filled outermost cell, which has 8 electrons, show little chemical activity. Yes, my dear students, it means outermost electrons are combined. Yes, it means formation of what? 8 electron. It is termed as octet configuration. Yes, it means the little chemically active. They are highly stable. Such elements are called inert. It means their valency is 0. Yes, my students, in an periodic table, 18 group elements are termed as what? The stable elements. It means inert. For example, helium atom has 2 electrons in its outermost cell, and all other elements have atoms with 8 electrons in the outermost cell. It means helium is duplet. It may having what? 2 electrons in an outermost cell. That's why that is termed as what? Duplet configuration. And all other elements have, it means present 18 group have 8 electrons in the outermost cell. Yes, my students, the tendency to react with atoms of the same or different element to form molecule is an attempt to attain fully filled outermost cell. It means that atom react with other atoms in order to attain fully filled outermost cell. An outermost cell which had 8 electron is called an octet. Yes, my dear students, it means fully filled water. 8 electron, that is termed as what? Octet structure as well as octet configuration. Atoms would thus react so as to achieve an octet in the outermost cell. This was done by sharing, gaining, or loss of electron. How it takes place? It takes place how takes place by sharing, sharing, gaining, or the loss of electron, or the loss of electron. Yes, my dear students, the number of electron lost or gained or saved by an atom to become stable or to achieve an octet in the outermost cell is known as valency of that element. Yes, my dear students, it means in other word, it is the combining capacity of the atom of an element with the atom of other element in order to complete its octet. Yes, it means that it is the combining capacity of the combining capacity of the atom of element with the atoms of other element in order to complete its octet. Yes, my dear students, it means some valences of groups I described below here. First one, first hydrogen, lithium, sodium, and potassium atoms contain one electron each in their outermost cell. Therefore, each one of them can lose one electron to become stable. Hence, valency is 1. Yes, my dear students. For example, hydrogen S1S1. In K cell only one electron is present. K cell only one electron present, and if one electron is termed as water, hydrogen valency is 1. Yes, my dear students. And lithium, second one is lithium Li3, 1s2, 2s1, nucleus, K cell and L cell. K cell 2 electrons, and in an L cell only 1. K cell 2 and L cell 1 electron. It means the valency of lithium is also 1. And third example is taken here, sodium electronic configuration 1s2, 2s2, 2p6, 3s2, 3p1 structure, K cell, L cell and M cell. K cell, L cell and M cell. Yes, in a K cell 2 electrons, L cell 2, 4, 6 and 8. In an M cell, 2 electrons. Okay, mean K cell accommodate 2 electron, L cell accommodate and M cell 3, in which S is completely filled. Okay, P means 1. Therefore, valency of electrons of much here? Only 1. Clear, my dear students? And now let us see. Second, the valency of each magnesium, calcium, beryllium is 2 because all of these have 2 valence electrons and they can lose these 2 electrons to make octet electrons in outermost cell to become stable. Is second one, the valency of each Mg, Ca and B between magnesium, calcium and beryllium is 2 is 2 is 2 because all of these have to have two two valence electrons. Let's take an example: magnesium Mg 12. Yes, electronic configuration 1s2, 2s2, 2p6, 3s2. K cell 2 electron, L cell 8 electrons, and M cell 2 electrons. Yes, it means valence electrons are here 2. Yes, my dear. So take another one example. Beryllium 4, electronic configuration 1s2, 2s2. Yes, it means K cell 2 electrons, L cell 2 electrons, and valency of electron or valence electrons are here 2. Yes, my dear students. Take another one example: calcium 20, 1s2, 2s2, 2p6, 3s2, 3p6, 4, 2. Yes, in a K cell 2, 8, and in M cell 6, 2. Yes, here valence of electron is 2. Yes, my students, let us see third one. The valency of boron and aluminum is 3 because each has 3 valency electron. Third one, the valency of boron and aluminum is 3 is 3. Yes, my dear students, boron and we take an example: boron 5, 1s2, 2s2, 2p1. Yes, it means K cell 2 electron, L cell 3 electrons. Valency of electron is equal to 3. Yes, my dear students, the same way the valency of carbon and silicon is 4 because each has 4 valence electrons. Yes, and nitrogen and phosphorus each has 5 valence electrons, so their valency is 3 because they can gain 3 electrons. Oxygen and sulfur each has 6 valence electrons, therefore their valency is 2 because they can gain 2 electrons are 2 electrons or share 2 electrons to complete their octet. Similarly, fluorine and chlorine each has 7 electrons. Their valence is 1. Yes, my students. Yes, calcium, Klm. Here 4s2, N8, N2. Valence electrons are 2. 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. 4s2. Yes, my dear students. Now, let us see what is meant by atomic number and mass number. The definition of atomic number and mass number. Atomic number atomic number is defined as the number of protons present in nucleus of an atom. Yes, my dear students, it is defined as atomic number is defined as it is defined as the number of protons present in the nucleus of an atom. Nucleus of an atom is called as what? Atomic number. For example, and also it is denoted by capital letter Z. Yes. And what is meant by mass number? Yes, my dear students, mass number means it is defined as the sum of number of protons and neutrons. Mass number. It is defined as defined as the sum of protons and neutrons, sum of protons and neutrons present in the nucleus of an atom. Nucleus of an atom. Yes, my dear students, it is represented by capital letter A. Yes. Now let us see what is meant by isotopes. All of you already know the definition of isotopes. Isotope means the atoms of the same element having same atomic number but different mass number. Yes, it is defined as the atoms of the atoms of the same element having same atomic number but different mass number. Yes. For example, 1H1, 1S2, 1H3. Hydronium, deuterium, and tritium. Yes, It means having the same atomic number, but difference in their mass number is termed as what? Isotopes. Yes, my dear students. Now, last discussion point is isobar. 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 Atoms of different element with different atomic number, but they have same mass number are known as isobars. Yes, atoms of different elements with different different atomic number at different atomic number, but same mass number are known as isobars. For example, argon 18, 14. The same way, calcium atomic number is 20, 40 are isobars. Yes, my dear students. Today we all discussed about what is meant by valency and some valencies of different elements. About the definition of atomic number and notion, and definition of mass number and notion, and definition of isotopes, and finally what is meant by isobars. Yes, thank you.